Hi everyone. Today we are going to talk about amplitude and period. We will learn what is the effect of changing the amplitude and period of a sinusoidal or periodic function. Any function like sine, cosine, tangent, and cotangent are called sinusoidal or periodic function because they repeat themselves after a period of their domain. I'm going to talk about all these keywords throughout the lesson gradually. So let's first of all start with graphing this function. Before that, let's go over transformation of functions a little bit. You remember we had y equal to f of x, and if we multiply that f of x by a number, let's say 4, that will be 4f of x. This 4 is going to vertically stretch your function by a factor of 4. So the same is going to happen here. The parent function is y equal to sine of theta, and we are multiplying that function by a number like 4. So we expect that this parent function is going to be vertically stretched by a factor of 4. Now I'm going to find the values of sine of theta for different angles. These angles that you see are quadrantal angles. So in order to find the value of sine of theta for each of them, we consider that we have a coordinate plane and a unit circle on this coordinate plane, and all these points are here. We find the coordinates of these points. This one is 1 and 0. This is 0 and 1 because this circle is unit circle and the radius is 1. So that's why these coordinates are like this. This one will be -1 and 0 and 0 and -1. And we know that if we have a point on a unit circle that has the coordinate of x and y, then x is cosine and y will be sine. Therefore, in order to find sine of any of these angles, we just need to take the y value of all these coordinates. So sine of 0 will be 0 because the y value here is 0. Sine of 90 is 1. 180 will be 0, 270 is -1, and 360 will be 0. Now I'm going to graph this parent function first. So when x is 0, y is 0, x is 90, y is 1, here. 180 is 0, 270 is -1, and 360 is 0. So this will be the graph of my parent function. Now let's talk a little bit about these keywords on our function over here. Cycle. A cycle is a section of a periodic graph before it repeats. We know that this function, sine, is going to repeat itself after this point, and also before this point it was repeating itself. So one section of this graph which is not repeating actually, or one section before it's going to repeat itself for another time, is called a cycle. So this is one cycle of this function. Period is the number of degrees or radians for the graph to complete one cycle. So how many degrees does this function need to complete one cycle? It needs 360 degrees, from 0 to 360. So we can say the period of this function, this parent function, is equal to 360 degrees. Or if we are working with radian, we can write 2 pi. Critical points. First of all, let's see what are critical points. Critical points are on this function are this one, 0, 90, 180, 270, and 360. Why do we call them critical points? Because critical changes are happening to our function at these points. For example, here the function was increasing, and right after this point it's decreasing. Here it was decreasing, and right after that is increasing. Also at this point, before this point the function was a downward curve, but after that it's an upward curve. So critical changes, as you see, are happening to this function at these points. Like in between them and at this point, not any major change is going to happen. That's why we don't consider that as a critical point. Okay, so how do I find critical points? To find critical points, we need to take the period of the function and divide that by 4. Why? Because in one section or one cycle, or in other words, in one period of this function, we have 4 sections between the critical points. 1, 2, 3, and 4. So that's why we divide by 4 to find these critical points. Basically, when we divide the period by 4, we find the distance between critical points. I call that CP just to make it shorter, critical points. So when we divide period by 4, we find the distance between them. Like how many steps do we need to go from one critical point to reach to the other one? The next keyword is sinusoidal axis. Sinusoidal axis is the horizontal middle of the graph. So this line that you see, the dotted line, is actually the sinusoidal graph of this function because it's passing horizontally from the middle of the graph. So for this parent function, the sinusoidal axis is at y equal to 0. This is the formula for sinusoidal axis. Then what is amplitude? Amplitude is the distance from the sinusoidal axis to the highest point or to the lowest point. So these two distances are the amplitude from here to here and from here to here. And I don't care if this is actually below the x-axis, so this is not a negative number. Amplitude is always positive. Always positive. So it's just the distance between the horizontal middle of the graph or sinusoidal axis to the highest or to the lowest point. So the amplitude of this parent function, I'm going to write just AMP, the amplitude is equal to 1. Now let's work on this new function, y equal to 4 sine of theta. To find the value of y for each of these angles, all we need to do is to multiply the previous values by 4. So this is 4 times 0, 0, 4 times 1, which is 4. 4 times 0 is 0. 4 times negative 1 is negative 4. And again, 4 times 0 is 0. So when x is 0, y is 0. When x is 90, y is 4. X 180, y is 0. For 270, it's negative 4. And for 360 is 0. So this will be the graph of the function. As you see, the parent function is just vertically stretched by the factor of 4. So the only thing that you see that is changed is the amplitude of the function. So the new amplitude for this function is equal to 4 because the distance between the sinusoidal axis and the highest or the lowest point now is 4. So amplitude is 4, but the period is the same thing. Period has not been changed at all because we're just vertically stretching this function. Also, we could consider the domain and range of these functions. The domain for both of these functions is from negative infinity to infinity because they're repeating itself before and after these points. But the range for this function, the parent function, range of the parent function is from negative 1 to 1 because for range we move from bottom to top and the lowest point is negative 1, the highest point is 1. So it's from negative 1 to 1. But for this new function, the range is from negative 4 to 4. So the range will change as amplitude of function is changing. So amplitude of y equal to 4 sine of theta is equal to 4. Now let's graph this one. Again, we're going to start graphing the function of y equal to 3 cosine of theta by graphing the parent function first. So this is the parent function. To find the values of cosine for all these angles, which are again the quadrantal angles, but this time in radian, we do the same thing that we did before. The points are 1 and 0, 0, 1, negative 1 and 0, and 0 and negative 1. This time, because we're looking for cosine, we just take the x values as the cosine of the angle. So cosine of 0 is 1. Cosine of pi over 2 or 90 is 0. For pi, it's negative 1. 3 pi over 2 is 0. And for 360 again, it's 1. Okay, so I can graph the function. Let's first of all write the value of all these angles here, which are basically the critical points as well. So this is 0, pi over 2. This one is pi, 3 pi over 2, and 2 pi. When x is 0, y is 1. X is pi over 2, 0. For pi, it's negative 1. 3 pi over 2 is 0, and 2 pi is 1. So this will be the graph of this function. This is the parent function. Again, the period of this function is the distance, or actually the number of degrees or radians that it needs to complete one cycle, and that is 2 pi. So period of this function is 2 pi. The range of the function is from negative 1 to 1. So range is from negative 1 to 1, because the lowest point is negative 1 and the highest point is at 1. Okay, now I'm going to graph the new function y equal to 3 cosine of theta. We just need to multiply 3 by the cosine, which we already found them here. So 3 times 1 is 3. This one will be 0. 3 times negative 1 is negative 3. 3 times 0 is 0. And 3 times 1 is 3. So when x is 0, y is 3. X is pi over 2, 0. For this one is negative 3. Then 0, and then pi at 3. So this will be the new graph of our function. Okay. So as you see again here, the amplitude has been changed. The amplitude of this function is 3. The highest point is 3. The sinusoidal axis is here at y equal to 0. This is the sinusoidal axis, and then the distance between sinusoidal and the highest and the lowest point is 3. So the range of this function will be from negative 3, that's the lowest point, to the highest point, which is 3. This will be the range of the function. So basically, from what we learned here, we can make a rule. If we have a function like y equal to sine of theta or y equal to cosine of theta, and we multiply them by another value like a number like a, then we have made a vertical stretch. That vertical stretch makes the amplitude of the new function change. So amplitude of the new function will be this value a that we have multiplied by this number. Now let's go to next page over here. When we have graph of y equal to 3 sine of theta, when we have this function, how do we graph this? So let's consider this 3 theta first. To graph this function, we need to find the theta on the x-coordinate. So how do I find that? I will say if 3 theta based on the value of 3 theta which is given. If 3 theta is equal to 0, then theta will be 0 divided by 3, which is 0. So theta will be 0. If 3 theta is equal to 90, theta will be 90 divided by 0, which is 30. So basically we need to divide each of these by 3 to get the theta. So this divided by 3 is 60, divide by 3 is 90, divide by 3 is 120. So we know that if we are trying to find these angles, basically the x value on the x-axis are these values. So these points will be our critical points. We will see that they are going to be our critical points now. So to fill this column, I'm going to find sine of 3 theta. So when x is 0, y will be sine of 3 times 0, which is 0. Sine of 0 actually. And sine of 0, we learned that is equal to 1. Oh, excuse me. Sine of 0 is equal to 0. For next one, we're trying to find sine of 3 times 30 because we're multiplying 3 by the theta that we just found. So it's sine of 90. Sine of 90 is equal to 1. Next one, sine of 3 times 60, which is 180. So this will be sine of 3 times 60, which is 180, and it's equal to 0. Then we have sine of 3 times 90, and that will be negative 1. Then sine of 360, which is 3 times 120, and that is equal to 0. So when x is 0, y is 0. When x is 30, y is 1. X is 60, y is 0. X is 90, y is negative 1. And x is 120, y is 0. So this will be the graph of function y equal to sine of 3 theta. We know that the parent function was y equal to sine of theta, which has the period of 360. But the period of this new function is 120. So the number of degrees that this function needs to complete one cycle is 120. So if I have y equal to sine of 3 theta, then the period of the function is 120. Now we can make a conclusion from here. What happened to the function? The period of the function is divided by 3 to get 120. Where did we get the 3 from? From here, because 3 was multiplied by theta. So that means multiplying the theta or the x value by a number gives a horizontal stretch or compression, and in this case it's a compression. We can go back to the transformation of functions, which we knew that if we have y equal to f of x, then y equal to f of, let's say, 3x will result to a horizontal compression. This is what we have learned before. So the same thing is happening here. This function was supposed to be something like this. It was supposed to be like this with a big period of 360, but now it's changed and now the period is 120. Okay, let's talk a little bit about domain and range of this function. The domain of this function is still negative infinity to infinity, although we have shrunk this function, but still it's going to repeat itself from back and forward, so it's still negative infinity to infinity. And then the range of function again is the same thing because we are not vertically making any change to this function, so it's from negative 1 to 1. So this will be from negative 1 to 1. Okay, so we can make a conclusion here. The period of sine of 3 theta is equal to 360 divided by 3, which is equal to 120. Now, there is a critical point like high, low, middle point every 30 units. You see the distance between the critical points are 30. How do we find that? We can say if the period of the function is 120, we divide that by 4. We learned this in the previous page over here. To find the critical points, we take the period and divide that by 4. So here again, we did the same thing. 120 divided by 4 gives us 30, which is the distance between the critical points. That's how we can find the critical points. Let's do another example here. Y equal to cosine of 2 theta. Okay, so if 2 theta is equal to 0, then we can say theta is equal to 0. If 2 theta is equal to pi over 2, then theta will be pi over 2 divided by 2, which is actually, because this is a fraction, to find a division, we multiply by the flip of the second one. It's 1 over 2. So this will be pi over 4. So we need to divide each of these values by 2 to get the x value. This will be pi over 2, and this one pi over 2. Divide by 2. Again, it will be 3 pi over 2 times 1 over 2, which will be 3 pi over 4. And then the next one, again, divide by 2. The 2's cancel each other. It will be pi. So we found the critical points. 0, pi over 4, pi over 2, 3 pi over 4, and pi. These are the critical points. Now, the value of the function at these points. This will be cosine of 2 theta for when x is 0. Cosine of 2 theta will be cosine of 2 times 0, which is cosine of 0, and that's equal to 1. Then the next one will be cosine of pi over 2. Basically, cosine of 2 times pi over 4, which is pi over 2. And that's equal to 0. Then we have cosine of pi. That's negative 1. Cosine of 3 pi over 2, it's 0. And the last one, cosine of 2 pi, which is 1. So now we can graph this function. X is 0, y is 1. X is pi over 2, y is 0. X is pi over 4, y is 0. X is pi over 2, y is negative 1. 3 pi over 4, 0, and 4 pi, it's at 1. So this will be the graph of the function. Again, the parent function, we know that the graph of parent function has a period of 2 pi. So this function was supposed to be something like this. But now it's shrink, horizontal shrink, because again, we are multiplying the x value by a number which is greater than 1. That causes a horizontal shrink to the function. Okay, so for this function, for this new one, the period of function is equal to pi, but the period of the parent function, which was y equal to cosine of theta, is equal to 2 pi. This one was for cosine of 2 theta. Is pi. Basically, the period of the parent function has been divided by these two values, and then we have the new period as pi. Again, the range and the domain of the function will not change here. Negative infinity to infinity is the domain. This was supposed to be a parenthesis. Now we can say there is a critical point here is happening every pi over 4 units. How did we get that? If we take the period of the function and divide that by 4, then we can find the distance between critical points. That is from here. We said critical points, period divided by 4. So we do the same thing, and here there is a critical point every pi over 4 point, which is the period of this new function, which was pi divided by 4. That will be pi over 4. Now we are going to make a general rule. If we have a function like y equal to cosine of b theta, or even y equal to sine of b theta, the period of the function will be 360, which is the period of the parent function, divided by this b value. Or if we're working with radian, it will be 2 pi divided by this b value. Also, if we have a graph of y equal to a sine of theta or y equal to a cosine of theta, then this new function has an amplitude of a. Okay, so this was today's lesson. Now I'm going to make another video for how to solve the problems on your homework. You can find the video for homework in the homework section of my website. Have a good day.